Hello, today we're going to do the surface area of pyramids and cones. If I go too fast, feel free to pause the video because there are some shapes you'll need to draw. The first shape we'll talk about is pyramid. We have to do the lateral area and the surface area. Remember, we do lateral area first. Lateral area is the area without the bases or base in this situation because pyramids only have one base. I'm going to start by drawing out the net. So I start with the base, and then I unfold the spaces from the point down. So then you get a net that looks like this. Remember that lateral area is all the way around without the base, so we're actually finding the areas of each triangle here. And when we combine that together, that's going to be the lateral area. Now there is a formula for the lateral area, so you don't have to find like each triangle and add together, but we're going to do that so that we derive that formula so you know where it comes from and what it means. Before we can do that, we need to talk about one thing. Pyramids have a special type of height. It's called the slant height. The slant height is actually the height on the face. So when I look at a face here and I draw in its height on the net, on the 3D solid, it's actually here and it goes down. It's 90 degrees here with the edge, but it's not 90 degrees with the base of the solid. So it's 90 degrees with the edge here, but not the base. We call that the slant height. We use a cursive L for it. So all the heights of my triangles in my net are actually going to be a cursive L so that we know that when we're talking in terms of the 3D shape, that's actually the slant height. The real height of the 3D shape is from here down, making 90 degrees with the base. That is where we're going to use an H. So make sure you know the difference. So again, lateral area for this is just finding the areas of those four triangles. So remember to find the area of a triangle, it's 1/2 times its base. So if I'm looking at this first triangle here, I don't know its base, so I'm going to use base 1 because I'm going to have multiple bases. And it's going to be times its height. Well, its height is going to be that lateral or that slant height, so I'm going to use the cursive L. And then I have to do that for each triangle, and they're going to have different bases though. So this one's going to have base 2, so 1/2 base 2 times the lateral, and then I have to add the third triangle, base 3. All right, so that's the start of the formula. We're not going to have to do this every time. Again, we're using this to derive a simpler formula for the lateral area. What I want you to notice is in each term, I have a half and a cursive L in each one of these. So they're actually the GCF of each term. So what that means is I can bring that out to the front like I would a GCF. So I can pull out a half and I can pull out an L. When I do that, the only thing that's left in each term are the bases, base 1, base 2, base 3, and base 4. So what's left is just adding those together. All right, so those, if I were to add those together, this is what it would look like on my net. I would be adding this, plus this, plus this, plus it's this. And if you notice, that's actually the perimeter of my base all the way around. So instead of having to write all of this out, we could just use that capital P to represent the perimeter of the base. So 1/2 times the perimeter of the base, capital P, times the slant height, L. That's actually the formula we're going to use. I just wanted you to understand where that P was coming from. So that's my lateral area formula for a pyramid. And now to find total surface area, I just take the lateral and I add the area of the base. I only have one base. So to find total surface area, you're going to take 1/2 the perimeter of the base times the slant height, and you're just going to add the area of the base. Now, with pyramids, the bases can be different shapes. So again, we're just going to use that capital B to represent the area of the base. We're going to have to refer back to the shape to figure out the shape of the base to determine what type of formula we need to use. We'll do an example of that in a couple minutes. I want to talk about a cone before we move on. So the lateral area of a cone. Again, the cone has a slant height. It goes from the top of the cone to the bottom. So I do have that cursive L slant height here. The true height of the cone, again, is going to be perpendicular with the base. So going from the top down to the base, making 90 degrees, is going to be the true height of the 3D shape. Now, to find lateral area, it actually uses the lateral area formula of the pyramids. Remember, we just found it. It's 1/2 the perimeter times the lateral, times the slant height. Now, the difference here, though, is I have a circle base, so perimeter is not really the right word. The other thing for perimeter, or the other word for perimeter when we're talking about circles, is circumference. Remember that circumference is 2 pi r. So when I put that into this formula here, instead of using the capital P, because a cone's always going to have a circle base, so I don't need to put the capital P there, I'm actually going to put in the circumference formula. Now, to simplify this, the 1/2 and the 2 actually divide each other out, so I'm left with pi r times the slant height. So that's the formula we're going to use from now on. Again, I showed it to you because I wanted you to understand why it's not 2 pi rl, because we're using that same lateral area formula for a pyramid with a cone. But because of the 1/2 here and the 2, they divide out, and that's why it's just pi rl. Now, total surface area is going to start with the lateral area, so pi rl, but we have to add in the area of the base. Now, again, with the cone, the area of the base is always, or the shape of the base is always going to be a circle. And the area for a circle is pi r squared. And I'm only going to have one base for a cone, so I just have to add in that pi r squared. And now that will give me total surface area of a cone. All right, so let's try some examples. First example is a pyramid, and I want you guys to find the total surface area. So we're going to find TSA of the pyramid. Okay, to find TSA of a pyramid, remember it's going to be 1/2 the perimeter of the base times the slant height plus the area of the base. Okay, so I got to fill in all those pieces. All right, so let's start with perimeter of my base. The shape of my base is a pentagon. Anytime I give you guys a polygon base, assume that it's regular. Remember, regular means that all the sides are equal. So to find the perimeter of a polygon, remember it's n times s. N was the number of sides, so I have 5 sides since it's a pentagon. And s was the side length, which is 10. So my perimeter is 50. So 50 goes here. And then the next is my L, my slant height. 12 is my slant height because it's on the face of the perimeter going down. So that's 12. And now I need to find the area of my base. This is where a lot of steps are going to come in. So I take a look at the shape of my base. The shape, again, is a pentagon. So I have to use the area of a polygon. Maybe use that formula, which, remember, was 1/2 the perimeter times the apothem. Well, lucky for us, we already have the perimeter. So I'll put that in. It's 50. But I need the apothem. I don't have that. So I'm going to erase this perimeter work so I have some room to find the apothem. So remember to find the apothem. The apothem is from the center down, creating 90 degrees in my little A. And it actually creates a right triangle. So I have a right triangle with an A. And remember, when we create that right triangle, it actually cuts the side length in half. So this is 5. And I need to find A. I don't have any other sides other than 5, so I have to find this angle here. Remember, to find that angle, you're taking 360, dividing by the number of sides, and then dividing by 2. When I do that, I get 36. So that angle there is 36 degrees. This is my adjacent side, and this is my opposite. So I'm actually going to use tangent to find A. So tangent of 36 equals the opposite of 5 over the adjacent A. Remember, when my variables in the bottom, we do the exchange of changes, those just flip around. So my calculator, I'm typing in 5 divided by tangent of 36. And I get 6.88. So my apothem is 6.88. Alright, so if I multiply that all together, I get 172. So the area of my base is 172. Alright, and then I just put that in the calculator. And the total surface area of my pyramid is 472. I actually have units. So I'm going to do inches squared. Lord almighty, this thing does not like me today. All right. Okay, so again, remember that this piece here is going to be determined by the shape that you have. Okay, so this one had a little more steps because I had a polygon base, and it's a little harder to find the area of a polygon. All right, let's try another example. Let's do a cone now. Again, I want you guys to find the total surface area of this cone. All right, the total surface area of a cone, the formula is pi r times the slant height plus pi r squared. Okay, so I leave pi, got to fill in the r, the l, and the r squared. All right, so my diameter is 18, so my radius is 9. So I can put 9 in for my r's. And the slant height I actually don't have. I have the true height, which is 22, but I need the slant height here, L. Okay, so if this is 9 right here, and the height is 22 and I need L, I actually can use Pythagorean theorem to find my slant height. So my slant height is 23.77. All right, so then I multiply stuff numbers together. We get 32.77 pi plus 81 pi. Both of these are like terms, so I can add the numbers together. And I get 113.77 pi centimeters squared. You could multiply pi through. You might have to on some of the things we do with the digital e-learning, but the most accurate way to write this answer is to leave pi there. All right, I believe we just have one more. I want to go through another combo problem with you. We need to calculate the total surface area. So again, I kind of break it down. The thing here I want you to notice is in the last combo problem that we did, we had some overlap. So if you remember, one of the sides was, we had a cube and then we had a circle because we had a cylinder sitting on top of the cube. So we had to find these little spaces since they were exposed to the air, so they're part of the total surface area. However, if you look here, it's a cylinder on top of a cone, so they're both circles, so they're overlapping each other. They have the same radius, meaning that the circles are the same, so there's nothing that's being exposed to the air. So I actually just need to find the lateral area of the cone. So only the lateral area of the cone, because the base isn't being exposed to the air, but the lateral area of the cone is. And I will need to find the lateral area of the cylinder. And I only need the area of one base of the cylinder, because again, the other base is with the cone's base and they're inside, they're not exposed to the air. So I don't need to add that in, and none of the pieces here, it's all one circle, nothing's exposed here. All right, so that's actually going to be my game plan in finding the total surface area. So again, I'm going to find each piece and add them together. So let's start with lateral area of a cone. All right, so the lateral area of a cone is pi r L. All right, my R is 7. And I don't have the slant height, so I'm going to have to find that, just like we did in the last problem. So I have to find L here. So it's going to be 24. I'm going to use Pythagorean theorem to find that missing side. So 24 squared plus 7 squared equals my L squared. So my slant height is going to be 25. I'm sorry that I do that. It's because it's an L, so I think lateral, and I know that's wrong. It's slant height. I apologize if that confuses you. I'm trying my best to remember. All right, so 25. So when I multiply that with 7, I get 175 pi. All right, then I have to find the lateral area of the cylinder. Remember that lateral area of the cylinder is the 2 pi r times the height. Okay, my radius, now the radius is still the same for the cylinder and the cone, okay, because they share the circle. So my radius is still 7. And then my height of the cylinder is 20. So the lateral area of the cylinder is 280 pi. And last, not least, we have to find the area of the base of the cylinder. We just need one of them. So area of a circle is pi r squared. My r is still 7, so I have 49 pi. And then I have to add them all together. They all have pi, so they can all be combined together. 175 plus 280 plus 49. So my answer for total surface area is 504 pi inches squared. Okay, so this one's a lot easier because there's no overlap here. They're both the same circle, so I don't need to do any subtracting. And that's how you find total surface area of cones and pyramids.